So, good morning, all of you. Myself, Dr. Lingaraju, Government First Year College, Tumkur University. So, my today's presentation of work is polyvinyl chloride and vitamin B changed ZnO molecule through as a green technique, that is structural, optical, and also morphological studies. So here I am going to present today 6 important points. One is introductions to nanomaterials, and also polymer nanocomposites, and also these nanocomposites synthesis and its structural characterization. And also we are going to study the optical studies through a morphological, and also finally conclusions. So here the introductions of this topic is, so nanoscale material. It is in this paper at first, in order to facilitate the modified of ZnO nanoparticles with the PVC matrix, and also in order to develop an appropriate content of dispersion, ZnO nanoparticles were modified with vitamin B as an organomodifier, and also biocompatible molecules through ultrasound radiations vitamin B as an organomodified and biocompatible substance through ultrasound sonication as environmental friendly, low cost and friendly. So knowing this, now here we are going to discuss the polymer nanocomposites. So polymer nanocomposites is, in a present study, we studied a fast and simple way to prepare nanocomposites through a direct mixing of nanocomponents without using a radical agents and polymerization process. The solution casting processing of material have lots of advantages and can be used to be a product with the appropriate price, lower energy requirement and fast reaction times. In other hand, the usage of ultrasonic irradiation is simple and also green and also low cost of preparation of nanocomposites. With the usage of ultrasonic, extraordinary reaction conditions like activation of surface, high pressure and also temperature is created for a very short time for a liquid. It cannot be achieved by other methods such as morphological or magnetic stirring. The mechanical mixing method does not homogeneous as well as ultrasonic method, and it does not give a desired depressions. So next, after knowing this concept, synthesis of ZnO vitamin B polymer of nanocomposites. So vitamin B1 was used for surface modification of ZnO nanoparticles. According to this point, for the synthesis of nanocomposites was poured into a diionized water by heating and continuous stirring to earn a clear solution, and subsequently was dispersed via ultrasonications for 50 minutes. In this next step, certain amounts of ZnO vitamin B1 nanoparticles is diionized water were dispersed, then sonicated for 50 minutes. The last step, the prepared suspensions of modified nanoparticles were added to the prepared solutions of polyvinyl chloride and sonicated for 30 minutes. Then prepared suspensions were moved to petri dishes and dried at 25 degrees Celsius to achieve the nanocomposites films. In the ultrasonic preparation of nanocomposites, the sonication was performed using a probe sonicator with the frequency of 20 kHz and power of 100 watts. That ultrasound proves is mixed solution systems. And also we are going to maintain around 1000 5000 K pressure of exceeding 1000 atmospheres. So the characterizations of this ultrasonic is the crystallinity and phase analysis of mass phosphorus. Nanophosphorus was carried out using a powder X-ray diffraction meter, radiation with a nickel filter. The scanning electron microscopy measurements were performed on a Hitachi table top. The diffuse reflectance spectroscopy of the sample was recorded on spectrometer by using a spectrophotometer. The photoluminescence measurements were performed. The optical properties of the samples were analyzed between 200 to 800 nanometers using ultraviolet with NIR spectrometer, coupled with an integration sphere for diffuse reflectance measurements. The band gap energy was calculated using the Km functions. The surface group of the ZnO was studied by FTIR. So then, after knowing this one, now here we are going to discuss some morphological analysis. So here in the diagram, so it is not clear. Just I will go to take my photos downward. We can see the sim images. These are the sim images. Surface morphology and dispersal of ZnO between B1 in polymer matrix were studied with a sim method. The sim micrograph of persistence PVC and NCS were shown in figure. For in a persistence PVC is a relatively smooth surface was observed, and the morphology of the PVC seems to be aggregate due to relatively tightly structural coherence between the polymer chains. However, for the nanocrystals containing the modified nanoparticles, rough and fracture surfaces have been observed morphology of pristine polymer and nanocomposites can be attributed to the use of sanications and modifier. The grafting agent caused a positive effect on the dispersion, and finally it has to be noted that the fabrication process including heating treatment and sanications directly affect the morphology of the persistence PVC. So after knowing this concept, so here in the optical contact angle measurements, here we are going to discuss. You see the diagram of A, B, C, D. So it having a percentage of weighting of these diagrams, it studies the sensorless drop method was used. The contact angle was measured by the tangent angle made between supported surface and liquid drop. The measurements were completed for all samples with the water at the room temperature based on the measurements of this concept. Nanocomposites hydrophilically was decreased for various quantities of a hydrophilic properties which come from the existence of hydroxyl groups in the PVC chain. On the other hand, PVC has various OH and CO groups in their structure. It caused their good hydrophilically as well as solubility of water by addition of NCS into a polymer matrix. Hydrogen bonding between OH and NH2 groups or modified NPS or polymer cause a decreasing in free of OH groups availability for the water interact with them. As a result, the polymer hydrophilically was decreased in increasing of nanoparticles content. So that is recorded as contact measurements. Next is FTIR studies, what we are observing in the graph. So that is the story band observed the region of 3400. You see 3400 is due at OH. Vibrations touching of PVC polymer. This broadband oriented due to the hydrogen related different states into the ZnO. The band at 297 you see in this point is attenuated with CH2 alphatic stretching and CH stretching rapidly. The bonds at 1739 corresponds to CO and also corresponding to CO and vibrations touching the bands of 649. 649 was due to vibrations touching of the ZnO band. Yes, this is about FTIR. Then the thermomagnetic gravimetric TGA, that is a TGA studies. As we can see from the figure that deviation, this deviation of nanocomposites from 200 to 300, 200 to 300 from here, from 200 to 300. In this point we are going to represent. So we can see in this graph, if we 200 to 300, this one, where this region represents the major decompressions of PNC owing to observations of humidity onset temperature increases with the increasing of the ZnO content of PVCs, which declare that the increment in thermal stabilities. Knowing this, just I am going to give the conclusions about my topic, that is the ZnO, VB, PVC and CS were prepared by users-friendly solution, casting route and characterized by various spectroscopic techniques. The hydrophilically decrease with increasing of ZnO, vitamin B1 content of PVC matrix. TJ result shows increase in thermal stability upon ZnO B1 content. Overall results clearly shows that optimized ZnO B1 and CS were quite useful for hydrophilic coating. Thank you one and all.